All right, so you should be seeing this screen, and there should be an edit button on the top right. And if you have not signed in or registered, you won't be able to edit. So you have to register first. Kaggle is a great website for data science and machine learning. So after this workshop, you can just scroll through the website and like look at other projects. So let me show you like how we can. So if you could not open the student handouts, let me show you. So when you join the link, like if you encounter this, just click the view the latest version. Or if not, go to versions, stay on the latest version, and press edit. So now you should be editing the student handout. Yeah. Does anyone have any problem with that? Is everyone okay here? Yeah. All right, then let's start. So yeah, so this is the third workshop of our UTMIST project workshop series, and we are today doing histopathological cancer detection. So in this workshop, we will be building a model that will compete at a histopathologic cancer detection competition on Kaggle, and you can find the link here. So let's look at the link. You are able to sign in and do the student handout, right? Okay. So this is the competition. As you can see, like on the background, we have some histopathologic images. So these are images of cells that have potentially tumor issues, and our job is to identify whether the cell has a tumor issue or not. And you can read through this and see what the competition is about. We will explain later as well. And so let's talk about the data we have. And in this data set, we are provided with a large number of small pathology images to classify. So we have about above 200,000 images, and the files are named with an image ID. The train label CSV file provides the ground truth for the images in the train folder. So if you want to see like the data you have, you can just click this and like go to the input, and you have like test and train data. And moving on, also confirm your version is 4, not 3. Stay on version 4. And moving on, you are predicting the labels for the images in the test folder. So before doing that, you will train on your train folder. A positive label indicates that center 32 to 32 pixels region of a patch contains at least 1 pixel of tumor tissue. Tumor tissue in the outer region of the patch does not influence the label. So the reason why the outer region is provided is to enable fully conventional models that do not use zero padding to ensure consistent behavior when applied to a whole site image. So we will talk about what this sentence means when we start building our model. So we will divide our project into 3 parts. So first part, we will try to understand what our data is. So we will closely investigate our data, look at our images, and then do some statistics with that. Because and next part is data processing, because like 80% of machine building is just processing data. Building the algorithm is like only 20%. And after processing our data, only then we will start building our model. And at the end, we will use our model to predict the images that we have not trained on. So let's start. So if you have a problem coming to this page, let me know in the chat. If not, let's start with the libraries. So we have a couple of libraries, and most of these libraries, we use them for every CNN project. And so keep in mind that these libraries are not specific for this project. So get familiar with these libraries after this workshop. And the first 3 libraries, excluding time, so let me do this. The first 2 libraries, we use them in most of our project, what's it called, Jupyter Notebook projects, to enable us to display better. And then this is our time library. So NumPy library is one of the most commonly used libraries. It's used for math operations, and pandas. Pandas and NumPy is like the backbone of Python. They are so essential that they have become like vanilla Python almost. And pandas is used for handling data and data frames. So CV2 is OpenCV's library. Maybe you have heard of OpenCV before. And we will use it to read images and transform them. So while I'm explaining these libraries, you can also run the libraries by clicking this button here. After you click, and then you click somewhere else, you can see it says 1 here. This means this is your first output. Like this is the first thing that you have run. So make sure you run the libraries and then click somewhere else to see the number here. And continuing on with the libraries, matplotlib, maybe many of you guys are familiar with this as well, is used for plotting. And TQDM is a library maybe you have not seen before. So we use this library to let's say you are iterating over a for loop, and let's say the for loop takes like 10 minutes. So if you do it on vanilla Python, you won't see the progress. You won't see when the for loop will end, and you will just wait. But TQDM allows you to see the progress bar, so you will see how it's progressing throughout the for loop. So it's a very useful library for that purpose. And matplotinline allows us to show the outputs on Jupyter Notebook. Again, we have a train test bit from sklearn, which is like the most common used library to split train and validation data or test data. We will talk about that as well. And we have PyTorch libraries that we will dive further into as we will go further with our model. So after this model, is everyone okay? But did everyone manage to run the importing libraries part? Yeah. So can I get some confirmation on chat as well? I see some emojis. Did you guys manage to run the libraries? Yeah. All right, then let's continue. Maybe can you guys type something in the chat, because I don't see anyone typing. Okay, just making sure it works. So okay, understanding and visualizing the data. So we will start setting the paths to the training and test data, and then we will split data into train and validation data, and then we will use data frame to visualize our data. So let's start with that. So if you could click this arrow, you can see the paths and you can see everything's under input. So that's why the first thing that we will do is set our path to input like this, and then we will give a backslash at the end. So this is our path, general path that we will use for everything. You can also see like this as well. If you could, for example, copy train data, copy the path. You can also see this, but we will just show it like this, and it should work as well. Path plus this, so what this does is it ensures our path to train is correct. And then we do the same thing for test as well. So this is the path to our test data. And now we want to read labels as well. So labels are here. And I want to read labels through pandas library called read CSV, because it's a CSV file. And I will just leave the path here as our argument. I do the same thing for submission as well. So I'm just going to say submission and then sample submission.csv. So, okay, let me give this a run if it works. Input train level CSV elements. So I think I need to add this as well. Yeah. Yeah. Yeah, I don't understand why. Oh, okay, it's train labels. And let me get rid of this as well. It's little issues. All right, so it works right now. I will call this train pad as well. So I'm changing a lot of things. Sorry guys. But we have some issues with the paths. Okay, so right now it doesn't give an error, but it's not complete yet. We want to split our data into train and validation as well. But you can see our data we have. So we have the path to the data, and we have the ID of the data, and we also have labels. So one means a negative label, so it doesn't have any tumor tissues in it. A positive label is 0, so it has tumor tissue in it. So we see that in the first 10 data, 4 of them doesn't have a tumor tissue, while the 6 of them has tumor tissue. So like from the first impression, it seems like equally balanced almost. So we want to split data into train and validation as well. And we will use the library that we have created here. So let me get this. And then here I will say train val equals to this. And then I want to split my labels into train and validation. But I want to split them so that like the proportion is the same for train and validation. So how can I do that? This library allows us to state the proportion. So I'm just going to say, hold on. I'm just going to say stratify. And then if I make this equal to the variable that I want to say the same, I'm just going to say labels.label. And I want to set the test size. So in this case, it's the validation size to 1/10 of the whole data. So what this does is it keeps the proportion of the negative and positive samples the same in train and validation data. And the validation data is 1/9 of the train data. So let me run this as well. So does everyone see this output? So the globe library, actually I've rarely used globe library, so maybe we can check this together. So we use globe library to find paths and path names, but in this case we manually input our paths, so we actually don't use the globe library. But it's a very good question. Thank you, Tamay. And we have someone new joined, so let me share the link as well with you. So for those of you that have just joined, please go to this link and edit the last version. You have to register first. So let me go back to the code. Did everyone have this output? Please confirm with me on the chat. If you don't see this output, let me know in the chat as well. Do you guys see the output? Or do you have a problem? Let me help you. So path is not inside. So you said path plus that. So you remove path plus. Oh, that is the same. So delete this. Yeah, delete that. Okay, yeah, go back down. So call this train path. Another one is test path. Did someone say anything? I couldn't hear. You guys are getting an error. Could you make sure this is like the thing you wrote? So we have path equals to the input, train path, test path, and we have labels, submission, train and val data. Okay. If everyone managed to do that, we can proceed. So we are given the load data function. So what this does, let's see. So load data function takes n as its input to load n images, and it takes the data frame as its input. So it's a pandas data frame. And so we will get 96 to 96 pixels, and we will display 3 channels. So these 3 channels means we will have RGB. So each of these colors is 1 channel. And their outputs are between 0 to 255. So this is the range for an RGB color. So this allows us to convert the array into like something that we can convert into image. And we are squeezing the label column to Y as well, so that we can get the first n labels. So we will see if it's 0 or 1 just by knowing its index. And we are iterating the data frame. And each time we iterate, we are using the OpenCV library to read image in the path, in this path. And we will assign this image, a red image, into the ith index of x. So this will, in return an x and y, such that x is like the image we want to show, and y is a label of that image. So how we can use this function? So first we will define n. Let's say we want to load 1,000 images, and we also want to use this functions like this. So we are inputting n as our input and also our data frame. So if you run this, it should not give you an error, but it should start loading the images. So it seems to stop at 99%, but it doesn't mean it stopped. That means it has worked, but for some reason it shows it like this. So if you see this, this means it worked. So this is a line of code that we wrote. Did everyone manage to write that? Can I see in the chat? Did it work? Yeah. Can you scroll to the train test split for a second? Yes, let me do that. Let me do this as well. So if you don't have any problems, I'm moving on. Sure, Emil. And so let's see what our data looks like, right? So this is where it starts to get interesting. So we are using matplotlib's library, and we will first set a random seed. So random seed allows us to get the same random images each time we run. So this is the perk of random seed, setting random seed, and we want to see 16 images. So how do we do this? So we are given a hint: iterate over a list of random numbers, then plot images with labels. So let me do that. So how do you iterate over random numbers? So in Python, maybe you have not seen this thing before, but there's this thing called, oh wait, I'm writing wrong. There's this thing called enumerate. So enumerate allows us to iterate over a list of numbers that you have just generated. So if I say enumerate np random and then dot rand int 0 and image count. So the first thing this does is it will generate a random list of numbers. So this list of numbers start from 0 and has a maximum value of n, and we have image count. So since image count is 16, we have 16 random numbers between 0 and n. And enumerate allows us to iterate over these numbers. And the syntax for that is you have the index of the numbers, and you also have the value of the numbers. So this thing we wrote, again, it generates a random list of number. It's iterates over random list of number, and then it gets the index of the number and also the number's value. So the index of the number, we will use it as the plot index, and the number's value, we will use it as the image index in the data frame we have. So let's proceed. After this, we want to add an X to our figure, and we will do this by adding a subplot. So we will say add subplot, and in this subplot, we want to have like 4 images, 4 plots in a row, and we want to have 4 rows as well. Let me say 4 and 4. So this is 4 rows, 4 columns for 16 images. And then my plot index, so the index that I plot is plot index plus 1. And let me see, I think this is enough for our X. And we want to plot image as well. So let me plot image show. This is again OpenCV's library, matplotlib's library. And then I just said image index is the index of the image, right? So I'm just gonna call the image index of X, if that makes sense. And I will plot the image there. And I also want to set a title as well. So I will set my title as the label of the image. And to find the label, I will find the label by going to the image index of Y. So this gives me the image, and this gives me the label. I want to convert this into string because I want to say label here like this. So let me run this if it works. I forgot one parenthesis. Yes, so it works. There's some problem with the distance, so let me see how I can fix that. Why did I say 1 and 0 means again? Where is the 1 and 0 means? Oh, okay. I got what you're saying. So 0 label is a positive label. So it means the image has a tumor tissue in it. 0 means the image has a tumor tissue in it. If the label is 1, that means the image doesn't have a tumor tissue in it in the center of the image. Yeah, makes sense? Okay. Sure thing. So does everyone have this output? Can I see some confirmation on the chat? Yeah, thank you, Tamay. All right, and I will proceed. Do you see this as well on your computer? Yeah, okay. So now let's analyze the positive and negative sample distribution or data to see if it has any bias. So we will plot bars, and this will be rather a simpler code. So we first want to calculate the number of negatives. And this is equal to the cases when y is equal to. Okay. So actually, label 0 is a negatives, I think. So we find the number of negatives by saying y equals 0. Yeah. And then we do the same for positives as well. So I just confuse the labels for negatives and positives. And then I would say negative samples equals the cases when y is equal to 0, and positive samples is when it's equal to 1. So I got the number of negatives, I got the negative samples, and I got number of positives and positive samples. And I want to plot a bar. So I will plot at the first and the 0th index of the bar. And I want to plot number of positives and number of negatives in the bar. Oh, it should be negatives. Moving on, I want to plot x labels as well. So I will say x6. So again, I want to have labels on the first index and the 0th index of my plot. And I will say, let's say like this, negative, and equals. So let's write it like this. All right. I'll copy this for post it as well. So don't forget your parentheses at the end. I'll do it like this so that you can see. And I will say plot y label as our number of samples. Must be string. Okay, so we have to convert to string. And this is our output. So Tamay, answering your question, negative images don't have cancer, positive images have a tumor tissue in it. So in our sample, 600 of them doesn't have a tumor tissue in it, if that makes sense. So we see it's kind of equal, not really equal, but kind of equal distribution. So it is good that here we said, let me go all the way back up. So remember when we said stratify equals tables and label, this ensures that the property is the same. So in the train, we have the proportion of positive samples 0.38, and in validation it's also 0.38. So this ensures that, and since the data is not really equal, it's a good idea that we did that. So we see the distribution. Now we want to have more idea of like how to tell a positive and negative sample apart from each other. So I will start off by explaining this line of code that we have. So here we will have like histograms. Histograms have bins. So if you don't know what a histogram is, let me show you a picture. So this is a histogram. In our histogram, we want to see how the brightness of image, the brightness of colors in an image is divided between positive samples and negative samples. What I mean by that? So we said each image has 3 channels: the red channel, the green channel, and the blue channel. And we said these values can change from 0 to 255. So if it's closer to 0, image is dark. But if it's closer to 255, it's more brighter. So let's say your red channel is like 180 and your green channel is like 30. The image would be more close to red than green. And so we set the number of means to 256. Because of that, we have like 256 outcomes. And we are plotting 4x2 plot. So we will have 2 columns and 4 rows of plots. And in each of these rows, the first row would be red row, the second row would be green row, then blue row, then RGB row. And we have 2 columns because in the first column we want to have the positive samples, and in the second column we want to have negative samples. So enough of the talk, and let's start actually plotting. So the first thing we have to do is iterate over the indexes we have. So for row index in range 0 and 4, because we have 4 rows and we have 2 columns as well. So we're iterating over rows and columns. And then, so you can see the first 3 are like individual channels, and the 4th one is the cumulative one. So the first thing I will do is I will confirm if we are in the first 3, then show the color channels, and else show the RGB cumulative. So if my row index is less than 3, so I want to confirm if my column index is 0. So if it's 0, show positive samples. And if it's not 0, you can say else as well, but I will just say elif. Show negative. All right. So what are we writing? So we have axis again, and we will iterate over the axis. So since column index is 0, I will just say 0 here, and we want this to be equal to the actually, let me make this histogram. So axis histogram, positive samples, and I will go through each. So the first one is the height, second one is the width, the third one is the channels. And I will just get the first one for red, second one for green, and third one for blue. So it's actually 0, 1, 2. But in this case, I will just say row index because that iterates over 0, 1, and 2. I want to flatten this as well. And finally, I want to set the bins equal to number of bins I have. And I want to set the density ester as well. So let me run this. Yeah, so I can't run it because of this. Let me just say, okay. So as again, we see, we started showing the positive images. So this is the distribution of red channels in positive samples, and it's the distribution of green channels and blue channels. So I will go back up here. I will do the same thing. So I'm just copying this for negative samples as well. But instead of saying positive samples, I will say negative samples. So if I run this again, yeah, I should put it on a different axis. So I'm changing this to 1, if you can see. Running this again. Yeah, so positive samples on the right, negative samples on the right. Well, let's label as well, right? And we will label here. So we will say axis. And we want to have the row index again. So at the 0 index, we want to set y label as our relative frequency. Yeah. And we want to set the other as the color's name. So I can just say, so remember we have an RGB list here. I will get that. And I want to get the row index. I want to set the rotation as horizontal. And I want to set the label head as 35. Finally, I will set the font size as 12. Yeah, so it's a little problematic. So let's see why the problem might happen. So I'm not really sure why this problem occurs. But we can just move on for now because it's a small problem. Yeah, okay. And as you can see, our last graph is empty because we have not plotted the RGB yet. So let's plot RGB as cumulative. So again, it's a very similar line of code here as well. I will just get the same cases that we have here. So I'm just copying this, pasting this, and there is this only one thing that I will change. I will just so instead of doing this, I will just delete this iterating process. So if I just delete this, it will not give me a single channel. It will give me the whole channel instead. Let's see. Yeah, so everything works. And if you want to add further labels as well, we can just say, let me write this quickly. So the first one is the positive samples, right? So I'm just going to say set title as the positive samples. And the other as the negative samples. So the distribution of positive samples and the distribution of negative samples. So let's start discussing. So while you write the code down, let me put my laptop to a charger. This was a little intense, I know, this function. It's just for visual purposes. So if you have a question, you can ask. So up to this point, how is it going, guys? Like, am I too fast? Or like, are you able to understand what I'm doing? Are you able to reciprocate what I'm doing? So like, any feedback on the chat is appreciated. Don't be like, shame. What are spikes at the end of the graph? So as you can see, the distribution of the red channels value, like it changes from 0 to 255. And it's rather a smooth distribution. But at the end, we see many images have the full brightness of red. So what that means is that the white color is not actually a color by itself. The white color occurs when you have the maximum output by red, green, and blue. So the colors closer to white, we have the maximum values of red, green, and blue. In this case, the maximum of, like, we are seeing a spike at the red, not at the green, but also at the blue. This means that it's like closer to white. So it's normal to see spikes at the end. Good question. So more white means there's a tumor right as done. So yeah, I was about to ask that to you guys. So if you would compare positive samples with negative samples, what are the things that you notice? So if type it in the chat, your observations. So let's start from like comparing channel by channel. So let's compare red channel of positive samples with red channel of negative samples. Like, what is the difference that you see between this? Compared to a positive sample, how red would you expect a negative sample to be? Would it be brighter, darker? So take your time and write it on the chat. Don't be scared to make mistakes. So like, it's a workshop. So Tanmay says distribution of red for positive samples centered around the middle. Less red than negative samples. That's perfect. Yeah. So we see that the negative samples are usually redder than positive samples. That's a very good observation. And in the green one, what do you guys observe? Do you observe the same thing for green as well? Yeah, I'm waiting for responses. Is red and green similar? Like, we know that negative samples are usually redder. Are they usually greener as well? So Tama says green follows up normal distribution for positive, but 2 peaks for negative. Yeah, that's right. Green is against standards around the middle. It's like a normal distribution for positive. So you can see positive samples are much smoother. They have a peak and then go down. On negative samples, they go up to the end, up to the bright colors, and then have a peak there, and sometimes have like 2 peaks. We can say the same thing for the RGB as well. In like the RGB is a cumulative of green, red, and blue, and you can see it's again a kind of like a normal distribution as Tamay said, and that's for positive samples. For negative samples, it again does not follow a normal distribution at all. It has 2 peaks, and it's much better than positive samples. So let's say you have 2 images of cells. The first image is slightly darker, and the second image is slightly brighter and slightly redder. So let's say the first image is 0, the second image is 1. So which image do you expect to be of a positive sample, and which image do you expect to be a negative sample? So let me write this down as well.
Question: What's the color values for the images that you gave us, like for the first one and the second one? Could you repeat that again, please?
Yep, I will write it in the chat as well. So image 0, dark image. Image 1, brighter image, more red. Which of these do you think is from a positive sample? Yeah, so this is the question in the chat. And I will wait for you to think about it. And when you feel free, when you think you have the answer, feel free to just drop it in the chat. So you can look at the histograms we have. As we said, the closer you are to 255, the brighter your image is. And this is like the cumulative RGB. So this helps you to understand the brightness. And this helps you to compare redness. Or does anyone have an answer? Do you guys have an answer? Were you able to follow? I will wait 1 more minute and then move on. Bless you. So yeah, we can say So image 0 is darker, right? And let's compare the RGB values for positive samples with negative samples. So as you can see, the RGB values for positive samples are like centered around 170 and follows a normal distribution. But for negative samples, it goes up to a high values, to like 220s, and it has 2 peaks there. So we would expect negative samples to be more brighter. Furthermore, if you compare the red channels, we can see positive samples are centered around 170, so expected values are around 170. But again, negative samples have a much brighter red color, so it's around 230. So I would expect a negative sample to be redder. So from these observations, we can guess image 0 is a positive sample, is from a positive sample, and image 1 is of a negative sample. So this was visualizing data. So let's start pre-processing the data, right? Let's start doing some more interesting things. So we will talk about transforming data. Now that we have our data, we want to turn it into something that our CNN model can take as an input. But in order to improve the accuracy of our model in the real world, we will use transformations. Transformations allow us to play with our data so that they are imperfect and unpredictable. So we will mention the methods that we will make this, like we can like flip the image, we can rotate the image so that like it's more unpredictable to our model, so that it doesn't overfit the data we have. So it intuitively sounds weird, but it actually helps us, our model, to have a greater test accuracy, because as I said, it prevents overfitting. Transformations also allow us to have more variety, which again improves the real-world application of this. So let's say like you have 1,000 pictures of cars, and you train your model on it, and if you flip the images so that your cars are flipped, that's actually another 1,000 image data you have. So like you can you doubled the amount of data you had, so your training model works better. So let's start by transforming our training data. So for transformations, we use the transforms library from PyTorch. So I'm just gonna say transtrain equals transform. So we will use compose. Compose composes multiple transformations. So I have to put this in a list. So in this list, we will list the transformations we have. The first thing that we do is transform it to a pill image. So pill images are easier for our model to work with. So it just converts our image to something that the model works better with. So we don't have to talk about it that much as well. So transform .pad is another transformation that we do. P is capital 64, and then we set the padding mode as replace. So this plays with the colors of our image so that it's less predictable. So again, it introduces variety. And as I said, we can flip our images to have more variety, and also make our model make our data more unpredictable, which will make it more ready for the real world. So I will say transform random horizontal flip. I will say the same thing for vertical flip. Some flipping horizontally and vertically in some of the cases. So like I think the default value is 0.5. So half of the time I flip the image horizontally, and half of the time I flip the image vertically. And then, so I will convert this image to tensor. So this is actually important, so I will talk about this. Our image has channels, height, weight, like its dimensions are height, weight, and channels. However, the PyTorch model doesn't work this order. The PyTorch model works with channel, height, weight order. So we want to change the order of our data. Two tensor methods allows us to do that very easily. So we are converting our image from the, as I said, height, weight, channel format to channel, height, weight format. So the tensor method is like used in every transformations. It's very useful. And then we will normalize as well. This is not always done. And in this case, we are doing so that the data is more unpredictable again. Like every time the idea is to make it more unpredictable. So I will set the mean around 0.5. I will set the standard deviation as a same list again. And I think that's about it. I think there's the transformations that we need for training. Transform, yeah, this should be transforms. Yeah, so each time I transform, it should be transforms, guys. So sorry about that. Let's change that quickly. File image. Underscore here. All right. So training transformation is like this. So in the chat, let me know if you have any questions about the transformations that we do, because transformations are essential. So like we visualize our data, and right now we are processing our data. So I need your 100% focus here, because this is like essential for like each model that we do, each machining project that we do. We need to transform our data. Yeah. You have your microphone on?
Is it live? No. Are you still in it? This is a meeting.
So we do a similar thing for validation data as well. So I'm just gonna copy this and then modify it from there. Tama, you have a question?
Yeah, I'm trying to run it and it gives me an error that I think there's a keyword that goes into the transforms.to tensor. Is there a keyword that goes in? Because it's not running. It's giving me positional argument follows keyword argument. But I think you will, if you run it, like you might get the same error, you might not get it. Mind running it real quick?
I read it doesn't give an error for me. Could you check?
Interesting. Yeah, I'll check and let you know. Thank you.
A possible error that you made could be you forgot to put commas, because I do that as well sometimes.
No, it's something else. I'll check and let you know. Thank you.
Okay. You can check the brackets as well. So I have like open parenthesis and then open bracket and then close bracket and then close parenthesis here. Could you confirm that as well?
Yeah, so I had an extra closed parenthesis. That's what I think is causing the issue. Thank you.
Great, okay. All right, thank you. Thank you for your question. Don't be afraid to ask question, guys. So I'm just gonna copy this after confirming it works and paste it here. So this was for train. I want to do it for validation as well. So let me go transvalid. So I will not do the same transformations. So I will not flip my data. I don't want to have that much variety in my validation data. Instead, I just want to have something that our model can work with. So validation data is not something that you play with that much. So because you are validating, right? but your training data, you want to introduce variety. So that's why you play with that. So I'm gonna run this again. And I will wait for you guys to copy and then move on. If you have any problems, I will leave the call in the chat as well, because this part is essential. So pasting from the Zoom chat usually is not the best. So yeah, be careful about that as well. All right, moving on, I have my dataset class. So let's look at what this is. So the first thing I do, I run this class. And then if you look at the class, you can see you have your data frame, you have your data directory, and you set your transforms here. Yeah, you have your length function, which returns the length of your data frame. And then you have your get item function as well. So when you want to get an item, you get your image name and label first. And then from that, it finds the, like, since you gave the path to your image, it goes to the path, it finds that image, it reads that image, and it returns that image with that label. So your dataset class basically gives you the image and label, given that you give your data frame, your data directory, and your transforms as your inputs. So now we have our datasets class. Let's create trained and validation datasets. So coming back to here, get trained and validation sets. So this is actually pretty simple because we have our class. So I'm just gonna say dataset train equals my dataset, which we defined here. Let's look at our parameters. We have our DF data. So what's my data frame here? If you remember, at the beginning of the code, we have like train and validation data frames. So I'm just going to say train here. And then my train path. And my train transformations, which I defined as trans train. So this is how I get my data set for train. I do the same thing for validation as well. Data set val. And good valid as well, so you understand better. And then val. This is val path. And then trans valid. We go back up. Yeah, so I don't have a thing called val path because my train data and my validation data is within the train path. Because remember, I split my train data into train and validation data. So I don't have a val data, I just have a train path here as well. My train and validation comes from the same data, but I just split the data into train and validation, if you remember that. So now I should have two data sets. Yep. So now I want to load train and validation data sets. For loading, we are using something called data loader. So in each of your CLM projects, like many of your machine learning projects, you will use this, and I will explain the idea in a minute. So data loader, data set equals data set train. We call this loader train. Loader train is equal to data loader. Our first parameter is dataset train. And then you will have batch size. I will explain that in a minute. And then we will have shuffle, which I will explain as well. we can also set non-workers to 0. So I will explain the parameters in a minute. I copy this, do the same thing for the validation data. So valid, and the rest is the same. I don't want to shuffle my validation, and I will explain this as well. And I will reduce the batch size by 2, divide by 2. I will explain what this means for now. Yeah, so we have not defined our batch size here, which is a problem that we are encountering. So before doing this, then we want to so let me keep this for later. So I just commented out this because this is not really pre-processing. This is like the model part. So I will do this step 4 instead. But I will explain batch size and other hyperparameters. So I'll just commenting out this to explain later, and we will just move on with our dataset train. All right. So now that we have our datasets, if you want to copy that, you can copy as well. So let me wait for a minute. Run this as well. And now I want to see like an image, like what my transformations look like. So I will start off with import random. I will set a seed. So again, setting a seed allows you to like, so let's say like I set seed 10. So I'm on the seed 10. This means that each time I run, I got the same number, but that number is random. But each time I run, I get the same number. So that's the idea of setting a seed. If I set it 20, it will give me a different number than what I set as 10. But each time, it will give me the same number that I run. That's why I set the seed. And then I get the random index as int random.random. And then I will just multiply this by the length of my data set. So my data set train. This is my random index. I'm choosing a random image. Image label equals data set train rand index. So I'm getting the image and label from my data set. And I want to show the image by, so I remember we changed the dimensions of our image, so we have to change it back now. So I'm just gonna say 1, 2, and 0. This again changes the dimensions. So remember, we change it to channel height weight. We are changing it back to height weight channel, because to display the image, you have to have this dimensions. So this is for displaying the image. This is for training the model. And then put the table as labeled. Sure. Yeah, this should be random.seed, not set seed. Okay, so we have this image here. So this is our transformation. We transformed our image into something like this. So you might wonder, like, how does this help the model train better? Like, it's interesting that like you are making your images worse, but your model trains better. This is because you're preventing the model from overfitting. So like if you give a perfect image each time, your model will train on it and will trust on perfect images. But you don't want your model to trust on perfect images. You want your model to be ready for like unexpected images, like unpredictable images. That's why you transform your images in your training folder. All right. Let me run everything again to make sure everything works. If you try like different seeds, you can see some crazy images. All right. So step 4, building the CNN model. Maybe you guys have been waiting for this, but trust me, it's quite easy and it's quite interesting as well. So we want to build a simple CNN model of 6 convolutional models, 6 convolutional layers, 6 batch normalization layers, additional pooling layers, and a fully connected layer at the end to connect nodes to an output. So then we will create a feed-forward function that will use leaky ReLU function to feed forward our model. So if you don't know what leaky ReLU is, let me show you the graph of it. So it's one of the functions used in machine learning. It has recently become more popular because of its simplicity. So if you're familiar with machine learning, you know that usually we don't actually use this. We use like other functions, like more sophisticated ones. For example, arc10x as a machine learning function. We use this function for other purposes maybe. But for neural networks, leaky ReLU has become really familiar because it's much easier, much faster to compute. So people use that. So let's start. So I will define a class. I will call my class simple CNN. And since, oh yeah, Tamay, go ahead.
So this may be a bit of a programming question. So when we have our dataset class called my dataset class,
Yeah.
The get function, the get item makes it so that whenever we use the class object, it automatically returns the transformed images and labels.
Yeah, so let me explain that. So if you have 2 underscores and 2 underscores in the front and 2 underscores at the back, that means you are overwriting the built-in functions of Python. So
Okay.
you know, if I say let me create a list length 5, 10, 15, this will return 3, right? Because length is a built-in function. So here I'm modifying the built-in function. So I don't change the length of the or get item. I modify that. So what is get item in Python? Get item is this function. So let's say let me create a list again. List equals 5 and 50. If I say list 0, I'm getting the zeroth item, right? The index of 0, like the first item of list. So this is actually the get item function.
Okay.
But if I do dataset train, for example, if I do it for my dataset actually doesn't have this functionality. So I just create that functionality for my dataset. How I do that? I overwrite the get item function and I return image and label. So I choose the return image and label.
Okay. Wow, that's something new that I learned. Thank you so much.
For sure. Beautiful question. So going back to our model, we are creating a simple CNN class. And since this is a PyTorch model, each time you create a PyTorch model, you basically, your superclass is an NN model. So this allows you to use PyTorch properties. So let me do that. And we want to initialize our model first. So let me do that. So we want to have 6 convolution layers. But before doing that, since we are implementing an NN.dot module, we want to call the super function of that. So if you are familiar with Python, maybe you understand what I'm saying. But if you are not familiar with Python, calling the super function is basically like this. So you do super simple CNN and self dot initialization. So this allows me to get the functions of an NN.dot module. So I have to call this. This creates a simple CNN class within an NN.dot module, within PyTorch classes. So right now I have a PyTorch model class. Through this, just by this code, I have a PyTorch model. But this is not enough. I want to create 6 combinational layers. So let me do that as well. Let's create our first combinational layer. So I will call combination 1. By adding self, I say that combination 1 is simple CNS instant attribute. And I say it equal to, I will use the NNN library again. I say convolutional 2D. My in channel. So my in channel is the initial channel I have. So in the chat, could you tell me what my in channel value should be? It's an integer. It's the number of channels that our data has. So how many channels does our data have? Each image. Type it in the chat, please, if you have an answer. So Tamay says RGB, so he says we have 3 channels. Do you guys agree? We have 3 channels? Yeah, that's correct. We have 3 channels, and in convolutional network, in like each convolutional layer, our goal is to increase the channel number each time, so that our model works, like our model generalizes the idea better. So we want to increase it to 32. So this is an arbitrary choice. You can make other choices as well. So I will set the kernel size. So do you guys know what a kernel is from the study groups if you have attended? If not, let me show you a simple kernel. So we talked about how our image has pixels, and each pixel has a different value. So we said red, green, blue values can change from 0 to 255. So our kernels, so let's say you have a 3x3 image. The kernel is basically a matrix that you multiply this image pixels with. And at the end, you have a smaller output. So it reduces the image size. And it generalizes the idea. So you can see that this image is brighter. So it is a brighter, like a higher value. But this image is darker because it's closer to 0. So it is a lower value. So the kernel allows us to achieve that. It generalizes the idea. So I'm setting the kernel size as 3. And I will set the panel size since kernel size is 3. So as you can see, my image was 3 by 3, but now it's reduced to 1 by 1. So we lost 2 pixels from each side. So I want to add these back. How I can do that? I can say padding equals 2. So what this does is, since I lost the boundaries here, like all the 2's, it will add all the 0's back there, so that it's again 3 by 3. So this is my first layer, convolutional layer. The other layers are not that much different. So I will just say self-com2 equals, so what's my in channel here? Could you type it in the chat? What's my input number of channels? A hint, look at the previous layer. So just type it in the chat. So yes, since the first layer has an input channel of 3 and an output channel of 32, our second layer has an input of 32. And for output channel, you can choose a number yourself. I just continue multiplying by 2. I do the same thing for third layer as well. So my input layer is obviously 64, and my output layer is, I again multiply by 2. My third layer. My fourth layer, my input channel is 128, output is 256. My fifth layer, I have 256, and then 518. And my sixth layer, I have 518 as my input, and I have 1024. Did I make a mistake? Yeah, this should be 512.58. My output is 1024. So this is my convolutional layers. I want to set batch normalization as well. So batch normalization allows our model to work much faster and much more accurate. Batch normalization was invented in, I guess, 2015. So it's a fairly new idea in machine learning, but it's very, very frequently used now. Normalizes the input. So my first one, I have 32 outputs, so my batch normalization is 32. My second batch normalization layer, I have 64 output channels. Then I have 128 output channels. Then I have 256 output channels. My fifth layer, I have 512 output layers. My sixth layer, I have 1024 output layers. So I will do some additional layers as well. I will do a max pool. So I will just say self.pool equals and then max pool 2D as well. So we are coming to the end of the model. So I'm just gonna reduce the kernel size at a stride. And then before ending our model, I want to add one final average layer so that we get the average of the inputs. So this shows the maximum of inputs for all of the inputs. And then this gives me the average. So like within like kernel size of 2, this gives me the maximum. And within the kernel size of 2, this gives me the average. Actually, let me change it to like 8. And let me call this self.average. I can't give it the same name. So before moving on, check if you have the same name for any two different things. So if that happens, that would give an error. Or even if it doesn't give an error, it will give an error later. So make sure each instance attribute has a different name. And finally, I am a fully connected layer. So the fully connected layer works like this. So we have a number of output channels, but at the end we have an output of like, it's either 0 or 1. We want to have this. Fully connected layer allows you to get all of these output channels at the end and connect them to 2 outputs. So I will implement fully connected layer as nn.linear. And there, I have 1024 outputs at the end, so I will just get that. And I will say I want to convert this into two outputs. So I get 1024 outputs converted to two classes. It's either 0 or 1, no other choice. This is my initialization. If you have a question, ask it in the chat. If not, I will move on. I will define a forward function. My forward function takes x as its input. So we mentioned that we want to use leaky value in our feed forward function. So let me just do that. I will say x as self pool, and then f leaky value. So f is the function that we have imported at the beginning. It's a PyTorch function. We are using the leaky value function. And then we are taking the second batch normalization first. And that takes in, oh wait, we are taking the first one first. Why did I stop on a second? We are taking the first batch normalization, and then that takes in the first convolution layer. First convolution layer, and that takes next. So let me explain the idea. We had a combination layer here, right? The first combination layer. We want to normalize that layer, the layer's output. So we put that inside batch normalization 1. That's what we do here. So combination layer takes x as its input. We take in batch normalization layer, and then we put the normalization layer into a leaky value function, as we talked earlier. I compared it with argtin(x), and now we just pull it, and this is our x now. So we modified our x, but we continue modifying our x. So this is our first one. In the second one, I'm taking the second combination layer and second batch normalization layer, and I will just keep continue doing this. Third layer. Each time I'm updating my x. And when I come to the sixth one, I will get the average of my layers, because I use the average function. And I have to modify the dimensions of my x. So I will just say x at x view. So since we don't know the dimension of our x, we will just say x at size 0. This allows me to convert x to something that I can work with. So this is like how we defined our CNN class, and so we define our feed forward function. And at the end, I will just put x through my fully connected network, and this is just it, because this gives me either 0 or 1. I return that value. So this is my simple CNN class. Let me run this. It's lagging. Just a minute. Okay. So now that you can see, this is my simple CNN class. We have 6 combinational layers, 6 batch normalization layers. We have additional max pool layer and average pool layer. And at the end, we fully connect each output to 2 channels, which is either 0 or 1. And then we have our full feed forward function that uses sleek ReLU. So if you have any questions, ask it in the chat. And I will give you some time to copy it down. Yep. All right, so if you have any comments, leave it in the chat. I'm answering some questions in person right now. All right. And we are moving on. This was our class. So we will set up some parameters. It's already given to you. Let me explain what these parameters mean. So number of epochs. So epoch is like, let's say you train your model once. You have a good model, but like once is not enough. You want to train it more because like your model now has a sense of what your data is, has a sense of what it implies. But like if you train it again, it will do much better because it only gets better. So number of epochs define how many times you train your model. So we will train it 8 times. Usually you will train it like 50 times, but within this workshop duration, I want to complete it, so I will just train 8 times. Number of classes, we have 2 classes. Your output is either 0 or 1. You are either positive or negative. Batch size. So we talk about batch size. I told you I will explain it. So batch size is basically, so let's say you have 100 image and your batch size is 25. This means that like usually you will think that you train your whole model and only then you will update your parameters, like update your weights. But your model improves itself every batch size time. So like if your batch size is 32, after training on 32 images, not the whole training set, it will update its parameters. It will learn from these first 32 images. So batch size is a very important idea to start training early on. It doesn't wait for the whole images it doesn't wait to study the whole image to train itself. It studies 32 images and then trains itself. So learning rate, we set it as 0.002. So if you are here, I assume you know learning rate. If not, learning rate allows you to, like using gradient descent, approach to the local minimum. And the smartest, the more careful it is by approaching the minimum. But if you set it too small, the training will take too long. So device configuration. So we are using CUDA. So CUDA allows us to, like, by using a Jupyter notebook, we don't train it actually on our computer. We train it on CUDA. It's a NVIDIA system. And like if we use CPU, our computer would like really get hot. But CUDA allows to like, so it doesn't really train on your local computer. So our device is very important in machine learning as well. And garbage collector, we just do it so that the CUDA is empty. So I can just say, I can just run this. So make sure you run that, the parameters. If you have a question about any parameter, let me know in the chat. And I will set my model to simple send on to device. Let's see. In channel. Let me see why this problem may occur. Interesting. Guys, each time I wrote in channel, it should be in channels. So I have to change each of them. Make sure you change them as well. It's in channels and out channels. In channels and out channels. Make sure you change those. Make sure you run the parameters again and run the model again. Let's give this in there. All right, now it works. So for backpropagation is where you improve your model. So feed forward, you send some weights to the forward of the convolutional neural network, but it doesn't really improve your model on data. Backpropagation is where it starts improving. So but did you change kernel size? So kernel size doesn't change. In channel comes in channels. Out channel becomes out channels. Don't change anything else. So this was a mistake I did. We fixed it fairly quickly. And as I said, backpropagation allows you to improve your model. So we have some optimizers provided by PyTorch. And Temme is getting kernel size and unexpected keyword arguments. So you wrote kernel, it should be kernel. So if you change that as well, so make it kernel size. So our optimizer is ADMAX. It's one of the stochastic optimizations. It's predictions, and we are using cross-entropy laws. So if you are interested about the formula, we can show it on Google as well. So we have a variety of cost functions in machine learning, but this one is the one that we fairly often use in neural networks. We use softmax, we use cross-entropy laws. It allows us to compute the error of our model. So if you can quantify the error of your model, you can also work on reducing that error. Like the closer it is to zero, the better your model is. So that's why cost function is very important, and your optimizer works on reducing that cost function. So now we will create our training loop. So as I said, we have 200,000 images. So if we worked on that right now, it will take like hours on working on Kaggle. So instead, I will just work on 1,000 images. So this line of code allows me to work on only 1,000 images. And I will create a training loop that iterates over the training set for epoch times and improves the model in each iteration. So it improves the model in each iteration, but we also said it improves the model in each batch size as well. So it keeps on improving. So let's start. We already have a template here for epoch in range num epoch. So in each iteration, let's see what we want to do. So the first thing that we want to do is define step and data count. This will allow us to see in which step we are at. Step, data count. So we set both of them to 0. And then we say start equals time.time. So we want to see how long it takes as well. Okay, so these are non-essential things. And then here's the essential thing. So for image and label, so let's say images and label, and we are iterating over loader train. So I remember I said I will define loader train later. So let me do that right now actually. So I go back to this line of code. I'm waiting for it to find loaders again. So it's right below my data set. Go back there. Uncomment this. And run the same. So this time it doesn't give an error. Why? Because last time it gave an error that we don't have batch size defined. But now that we have our batch size defined, I can run this. Let me run it again to make sure. Let me know in the chat if you couldn't find loader train. So let me explain what loader train does. So we have our images, we have our data set, but like we want to efficiently load our training data into our model. Data loader is a very commonly used library in like PyTorch in Python to load data. So we say like load data set train, but we also mention that for like in each after 32 iterations, improve the model. And we also enable shuffle, so like the data is kind of random. But in validation, we don't want that randomness. In validation, we want to validate our data, so we don't want any chaos. So I have my load train and load valid. I'm going back to here. So I'm iterating over the images I have. I have the images, I have the label in loader train. And I want to increase my data count by length of images because I don't. So each time I get 32 images. Why? Because my batch size is 32. So I don't get a single image. I get 32 images. I make use of my GPU and CPU. I run 32 images at the same time. So that makes your algorithm work much faster and much more efficient. So I will check if CUDA is available so that we don't run into errors. If torch.CUDA that is available, CUDA is available. I want to get images from CUDA and get label from CUDA. By the way, I said label here. I will say labels. Make sure you change it as well. Images and labels in loader chain. Images equals to images.CUDA. Labels equal to labels.CUDA. Make sure you change those. So now I got my images and labels. I want to see what my model thinks my output is. So I'm just gonna say output is equal to my model. I'm giving my images as my input to my model. So we said we have our cost function, right? Cost function and loss function, they are the same thing. So cost and loss. And we want our loss to be as close to 0 as possible. So I will say loss equals, let me get the loss function first. We define our cost function as criterion. So I'm going to say criterion and outputs. So output is what I guess, what my model guessed the label is. The labels is the actual label. So it compares these two and gives me a loss value, like how far apart I'm from truth. Loss value is like how wrong am I? And I want to be wrong like as 0. So I run my optimizer as well. I run my optimizer as 0 grad. Again, to have more information on optimizer, like ADAM-X, ADAM, stochastic optimizations. We don't have much time in this workshop, so I will, if you want to like talk about it later, I can talk about it later, or I can share some research on optimizers as well. I will share it on the Discord channel actually, so that you can have more information. And now that we have used optimizer, I want to do backward propagation. How do I do that? I say loss.backward. And this is my function. So loss.backward makes me do backward propagation, improve the weight of each node, and improve the accuracy of my model. After doing that, I'm just going to say optimizer last step. And I guess that's it. This should be my training group. I'm just going to give it a little run. Criterion is not defined. Let me see. Did I run this one? Yeah, I forgot to run this line of code. So if you have forgot as well, run it. After you run it, come back here, run this, and then we say outputs is not defined because I say output. I have to say outputs. So it's really easy to fix errors in Python. This is one perk of Python. We start running our model. So as you can see, we have our training loop, and one epoch is already completed. So this iterates 8 times, and each iteration we have different step sizes. So like our batch size is 32, and we can see how the model actually works. Like we can see the loss value and kind of ranges, but like it is not strictly decreasing, but it is decreasing. All right, so we are at the 6th epoch. So if you have any question, write down chat. I can help. if we have encountered any errors. While this works, I will go back up here. So this is the line of code that we wrote. If you want to copy it down, so does everyone have epoch working? Like, is your training group working? Do you see the iterations? And we ended at a good number of 0.32 loss. So we want to test our model. So I gave you the function for testing the model. We just want to define one thing. So I have a question in the chat. Could you put the code in the chat? Sure thing. So I will share the solution file as well. But if you want to follow along, I will give you the code here. The indentation is wrong though. I don't know why Zoom does that. Yeah. They should be all aligned, except the body of if. All right. So if I could grab your attention here for calculating the accuracy. So we have the number of correct guesses and we have the total number. And this calculates like the number of correct guesses, the number of total numbers, like it iterates over the valid function. So if you remember, we define a validation set. Validation set allows us to validate our model. So we calculate our accuracy here. So before moving on, I have another question in the chat. Yeah, so that error has to be because of your simple class. I think your out channels is different from mine. So I have like 1024, 1024, 1024 here. Check if you have the same values, 10 May. Are they the same?
Yeah, so mine was, the last channel was like 3 instead of 1024. I just changed it, so I'm gonna try it again. Thank you.
For sure. So again, I have the number of correct guesses. I have the total guesses. I want to calculate accuracy. So it's a very basic math function. So could you type in the chat what my accuracy should be so I can calculate it in terms of correct and total? Yes, thank you, Emil. Great answer. So my accuracy is correct divided by total. And if I want to see this as a percentage, I can just multiply this by 100 and I can start testing my model. So I'll give it a little time. Again, for the duration of our workshop, we reduced the testing size to 2000 instead of 22,000 test images we have. We have a good accuracy of 83%. So well done, guys. We have a very good accuracy. And if we just worked on like 2% of the data that we actually have, like even less than that. I think we worked on 0.5% of our data to work faster. So if we work on the whole data, our model actually has a capability to reach 95% accuracy. So we just reached this with 10 minutes of training, like five minutes of training. So now this is actually our model. We actually made our model, we improved our model, and we tested the accuracy of our model. So that's actually basically it. And if you want to submit your model to the competition, you can just write these lines of code. And it will take some time because you can't reduce the size there. You have to actually test the model on the whole test data. So it will take some time. So I'm just going to skip that. But if you want to do it on your own time, on your own free time, you can do that. So that's basically the workshop. If you want to see the solutions of the workshop, I can show you that as well. Let me save this version. So it is saving here. Why is it saving here? So if you again go back to this page, you see version 405. So I'm just click that. I click this. It is not saved yet. Let's just give it more time. And now it works. So I go back to the site, end of workshop, and you can see the whole code here. So if you wanna, like, if you have an error in your code, you can just compare it with this, or you can just start editing this code to see like the actually how the model works. But that's basically the workshop. So if you have any comments in the, any questions, just leave it in the chat. And it was a pleasure to do this workshop with you guys. Thank you. So if you have any questions. Thank you guys. Pleasure to help you. All right, then I'm leaving. I'm stopping the record. I'm stopping the share as well. Can I apply to be a cancer researcher now? Yeah, sure. I mean, you can apply, but I don't know if you get accepted. All right, let me stop the recording.